Have you ever wondered what it would look like to send a camera soaring into space on nothing more than a balloon? It started with a spark of curiosity, a simple yet profound question about capturing Earth from a vantage point few will ever experience. Armed with a small camera, a weather balloon, and big dreams, one individual set out to explore the unknown. It wasn't about flashy rockets or billion-dollar budgets, just pure ingenuity and a desire to see the world differently. As the balloon ascended higher and higher, passing through clouds and into the inky vastness of space, the images it captured were breathtaking. But what happened next was truly unexpected, sparking debates, inspiring awe, and even challenging long-held beliefs about our planet. Stay with us as we unpack this incredible journey, the stunning footage it produced, and the ripple effect it created across the globe. From the highs of triumph to the surprises along the way, this is a story that reminds us just how vast and yet connected our world truly is. The spark of curiosity. Let's set the stage. It's a quiet evening, and a man sits in his small workshop scrolling through YouTube, marveling at videos of amateur science experiments. One video shows a weather balloon carrying a camera into the upper reaches of the atmosphere, capturing jaw-dropping footage of Earth from above. The idea plants a seed in his mind. Why not try this myself? With curiosity as his only guide, he starts researching what it would take to launch his own camera into the stratosphere. What started as a passing thought quickly becomes an obsession. The man dives into online forums, consults with amateur space enthusiasts, and learns about the tools required: a weather balloon, a payload rig to hold the camera, a parachute for safe descent, and most importantly, a GPS tracking device to retrieve the camera after landing. This wasn't just about creating a beautiful video. It was a test of creativity, resourcefulness, and determination. After weeks of planning and preparation, the project was finally ready. Designing the experiment, the first hurdle. Budget constraints. Unlike big-budget space agencies, this was a one-man operation. The entire experiment had to be affordable. He chose a lightweight action camera with a fisheye lens for its wide-angle capability and durability. But even the simplest setups come with complications. For instance, how do you ensure the camera survives extreme cold at high altitudes? The solution: insulating the camera in a styrofoam box lined with hand warmers. Next, he needed to calculate the balloon's lifting capacity and ensure it could carry the payload. Too heavy, and the balloon wouldn't ascend. Too light, and it might burst prematurely. Balancing these factors required precision. Then came the GPS tracker, a crucial element to locate the camera once it returned to Earth. Without it, this entire endeavor risked becoming a one-way trip. Challenges and problem-solving. Every great experiment faces setbacks. In his case, unpredictable weather posed a major challenge. High winds could blow the balloon miles off course, potentially losing the camera forever. After researching wind patterns and consulting weather forecasts, he picked a calm day for the launch. Then came the issue of obtaining permissions. Launching an object into the sky isn't as simple as tying a balloon to a string. Regulations require clearance to avoid interfering with air traffic. He had to file his flight plan with the relevant aviation authorities, detailing the balloon's expected path and maximum altitude. 4. Preparing for liftoff launch day arrived, brimming with anticipation. The camera was securely fastened, the GPS tracker was tested, and the parachute was attached to the rig. The weather balloon lay deflated on the ground, waiting to be filled with helium. Friends and family gathered to witness the moment. As the helium filled the balloon, it began to expand, its sheer size growing more awe-inspiring by the second. The countdown began. 5, 4, 3, 2, 1. With a gentle release, the balloon lifted off, taking the camera along for the ride of a lifetime. The launch. The first moments of ascent were magical. The balloon floated gracefully, gaining altitude with every passing second. Below, the spectators watched in amazement, their cheers fading into the distance as the balloon soared higher and higher. From the camera's perspective, the journey was equally mesmerizing. At first, it captured familiar sights, fields, buildings, and cars. But as it rose, the landscape transformed. Trees became patches of green, roads became ribbons, and cities turned into tiny grids. 6. Ascending through the atmosphere. As the balloon ascended, it passed through the layers of Earth's atmosphere, each with its unique characteristics. The troposphere, closest to the ground, was filled with clouds and weather patterns. Beyond that was the stratosphere, where the temperature dropped sharply and the sky transitioned from blue to deep black. The camera captured it all: the layers of the atmosphere, the curvature of the Earth, and even the gradual fading of sound as the air thinned. 7. Unexpected views. At its peak altitude, around 100,000 feet, the footage revealed something extraordinary. The curvature of the Earth was clearly visible against the backdrop of space. The sun appeared as a blazing sphere, casting light across the planet below. The horizon, a blend of deep blue and black, created a contrast that was both haunting and beautiful. However, the journey wasn't without surprises. The fisheye lens distorted the horizon, leading to an effect where the Earth's curvature seemed to wobble with the camera's movements. While this added an artistic flair, it also sparked debates online. Was the curvature real, or an illusion created by the lens? Scientific significance. Beyond the breathtaking visuals, the experiment had deeper implications. The footage provided a glimpse into the fragility of Earth's atmosphere, a thin, delicate veil that shields life from the harshness of space. Scientists often discuss how small our planet appears in the vastness of the universe, and this project offered tangible proof of that reality. But the most unexpected result: the sheer accessibility of space exploration. This wasn't NASA or SpaceX. It was a person with a dream, proving that the barriers to space aren't as insurmountable as they seem. The controversies. As word spread about the experiment, the online community erupted with discussions, debates, and heated arguments. The video footage, while undeniably stunning, sparked controversy in unexpected ways. Some praised the visuals for showcasing Earth's beauty, while others scrutinized every frame, looking for inconsistencies or proof of tampering. The most polarizing topic? The curvature of the Earth. Critics, especially flat Earth theorists, argued that the fisheye lens had distorted the horizon, exaggerating the appearance of a curve. "Look closely," one comment read. "The curve flips depending on the camera angle. That's proof it's just lens distortion." Proponents of mainstream science were quick to counter, citing the consistency of the footage with known physics and observations. The discussion quickly moved beyond the footage itself. Debates on scientific literacy, conspiracy theories, and the power of amateur science experiments lit up forums and social media. The lens debate. To fully understand the controversy, let's dive into the lens debate. A fisheye lens, like the one used in this experiment, is designed to capture a wide-angle view. However, this comes with distortion, especially around the edges of the frame. The distortion was evident from the footage. At certain angles, the horizon appeared unnaturally curved. When the camera tilted during the balloon's ascent and descent, the curve seemed to invert, creating a concave effect. But here's the kicker. Even with the lens distortion, there were consistent markers of curvature that aligned with physics. Observations from high-altitude footage taken without fisheye lenses also showed similar results. This raised a crucial question: how much of what we see can we trust? Reaching maximum altitude. After roughly 90 minutes of ascent, the balloon reached its peak altitude, approximately 100,000 feet above sea level. At this height, the Earth below looked surreal. The land masses, oceans, and clouds formed a mosaic against the blackness of space. The sun, unhindered by atmospheric scattering, shone with a sharp, almost unnatural brilliance. The camera captured moments of silence and stillness that felt otherworldly. However, the apex of the journey also marked a critical point. The balloon could no longer withstand the pressure difference between the inside and the surrounding atmosphere. With a sudden, dramatic pop, the balloon burst, sending the camera and its rig into free fall. The return journey. The descent was just as thrilling as the ascent. With the balloon no longer buoying it upward, the rig plummeted through the stratosphere at incredible speed. The attached parachute, designed to deploy automatically, unfurled after a few seconds, slowing the descent to a safe speed. As the camera tumbled, it captured dizzying footage of Earth spinning below. The rapid change in perspective provided an entirely new way to appreciate the planet's vastness and diversity. The patches of green, brown, and blue grew larger as the rig fell through the atmosphere. Tracking the camera during its descent posed its own set of challenges. Would the GPS signal remain stable? What if the rig landed in a forest, a body of water, or an area inaccessible by foot? The team monitoring the descent anxiously watched the GPS feed, hoping for a smooth retrieval. Touchdown. After several minutes, the rig made its final descent, landing in an open field. Remarkably, the camera and its equipment were intact, shielded by the protective casing and cushioned by the parachute. The retrieval team breathed a collective sigh of relief. As they approached the landing site, they were greeted by an astonishing sight. The camera, still recording, had captured the final moments of its journey. The blades of grass, the gentle sway of the parachute, and the shadows of clouds overhead. This wasn't just the end of the journey for the camera. It was the beginning of a new chapter in understanding and sharing what it had captured. Analyzing the footage. Back in the workshop, the man eagerly downloaded the footage, poring over each second with awe and fascination. The video began with the chaotic launch, transitioned into serene views of the stratosphere, and culminated in the dramatic descent. The raw footage was breathtaking, but it was also full of data. The camera had captured subtle atmospheric changes, shifts in light, and the unique interplay of Earth's curvature with the surrounding void of space. Editing the footage was a meticulous process. The man balanced preserving its authenticity while enhancing clarity and detail. He added timestamps, altitude markers, and overlays to help viewers understand the context of each moment. Reactions from the online community. When the finished video was uploaded to YouTube, it quickly gained traction, amassing thousands of views within hours. The comments section became a battleground of ideas. Some viewers marveled at the beauty of the footage. "This is the kind of video that makes me believe in the magic of science," one commenter wrote. Others expressed skepticism. "Cool visuals, but let's be real. The fisheye lens makes everything look round. Try it again without it." And then there were the conspiracy theorists. Clearly staged by NASA. Wake up, people. The Earth is flat. Despite the diverse reactions, one thing was clear. The video had captured the imagination of a global audience. It wasn't just a scientific experiment, it was a cultural moment, inspiring discussions about science, technology, and the nature of exploration. The flat Earth angle. The video reignited a long-standing debate that has persisted in certain corners of the internet. The flat Earth theory. Flat earthers dissected the footage frame by frame, seeking evidence to debunk the spherical Earth narrative. "Notice how the horizon shifts from curved to flat and even concave at times," one commenter pointed out. "This proves it's just the fisheye lens playing tricks." Others latched onto the camera's movement during the descent, arguing that the wobbling horizon was further evidence of manipulation. Mainstream scientists and enthusiasts were quick to counter. They explained how lens distortion works and provided comparisons with footage from other high-altitude balloons equipped with standard lenses. "The curvature of the Earth is consistent with physics and data collected over centuries," one user argued. Despite the rebuttals, the debate persisted, with each side using the footage to bolster their arguments. While the man behind the experiment hadn't intended to wade into such controversies, his project had inadvertently become a focal point for a much larger conversation. Technological insights. Beyond the philosophical and scientific debates, the experiment offered fascinating insights into the technology that made it possible. The camera's durability was a standout feature. Exposed to freezing temperatures, high winds, and thin air, it continued recording without interruption. The insulation, a simple styrofoam box and hand warmers, proved surprisingly effective, shielding the sensitive electronics from the extreme cold of the stratosphere. The GPS tracker, a critical piece of equipment, functioned flawlessly despite the harsh conditions. It transmitted real-time location data, enabling the retrieval team to pinpoint the landing site within meters. Then there was the parachute. Made of lightweight nylon, it deployed perfectly, reducing the impact of the descent and ensuring the camera's safety. Each piece of technology, though simple on its own, worked in harmony to achieve something extraordinary. Environmental concerns. While the experiment was a success, it also raised important questions about its environmental impact. The remnants of the burst balloon, for instance, were a concern. Latex balloons typically decompose over time, but the risk of harming wildlife or leaving traces in remote areas was real. To address this, the man took extra precautions. He used biodegradable materials wherever possible and ensured all components of the rig were retrieved. He also joined conversations about responsible practices for similar experiments, emphasizing the need to balance exploration with environmental stewardship. Next steps in exploration. Buoyed by the success of the project, the man began considering what might come next. Could he improve the experiment with better equipment? What if he collaborated with other amateur scientists to tackle more ambitious goals? One idea was to send a 360-degree camera into space, allowing viewers to experience the ascent and descent in immersive virtual reality. Another was to equip the rig with scientific instruments to measure temperature, pressure, and radiation levels, adding a deeper layer of data to the visuals. He even entertained the thought of forming a community of enthusiasts dedicated to low-cost, high-impact experiments. The possibilities were endless, and the journey had only just begun.
Ongoing discussions. The impact of the experiment went beyond the footage and debates. It became a symbol of what ordinary individuals could achieve with curiosity, creativity, and determination. Online forums buzzed with discussions about amateur space exploration, and people from around the world shared their ideas for similar projects. Educators saw potential in using such experiments as teaching tools, inspiring students to engage with science and engineering. Some schools even reached out to the man, asking for advice on how to replicate the project for their own students. The conversation wasn't just about the shape of the Earth or the beauty of the footage. It was about pushing boundaries, embracing the spirit of exploration, and reminding ourselves that the universe is vast and full of wonder. Inspiring citizen science. The video became a rallying point for the growing citizen science movement. It showcased that one person, armed with determination and basic tools, could achieve something extraordinary. The experiment was a reminder that science isn't reserved for professionals in lab coats or billion-dollar corporations. It's a pursuit anyone can engage in with a curious mind and a willingness to learn. Inspired by the success of this project, individuals worldwide started planning their own experiments. Some aimed to launch balloons to capture similar footage, while others expanded the idea with new innovations like multispectral imaging or real-time telemetry. The accessibility of the equipment, a weather balloon, a lightweight camera, and a GPS tracker, meant these experiments were within reach for hobbyists and schools alike. Social media platforms buzzed with the hashtag #CitizenSpace, where participants shared designs, tips, and results. A movement was forming, one that democratized space exploration and made science more approachable. Collaborations and outreach. As interest grew, the man behind the project began receiving messages from researchers, educators, and fellow enthusiasts. Universities expressed interest in collaborating, offering access to advanced equipment in exchange for the opportunity to work on similar experiments. One notable proposal came from a group of educators who wanted to develop a curriculum based on the experiment. The plan was to teach students the basics of atmospheric science, engineering, and physics, using the balloon experiment as a centerpiece. Students would get hands-on experience designing payloads, predicting flight paths, and analyzing data. This wasn't just about science. It was about inspiring the next generation of thinkers, inventors, and explorers. The global perspective. The experiment also sparked conversations about the interconnectedness of our planet. Seeing Earth from such a high altitude offered a perspective few ever experience. It reminded viewers of our planet's fragility, the thin atmosphere that protects us, and the need to care for this shared home. Environmentalists praised the footage for its ability to evoke a sense of stewardship. "Looking at the Earth like this," one commenter wrote, "you realize just how small and precious it really is. We have to take care of it." The footage also sparked interest in global cooperation. People from different countries began sharing their own perspectives on science and exploration, creating a virtual space where borders dissolved and curiosity united. Expanding the scope. With the experiment's success, new ideas began to take shape. What if the project could go beyond visuals and contribute to scientific research? There were discussions about equipping future flights with sensors to measure ozone levels, monitor air quality, or study atmospheric pressure changes. One ambitious idea involved using the balloon to carry seeds into the stratosphere and expose them to extreme radiation. The goal would be to study mutations and explore their potential for creating hardier crops. A concept inspired by space farming experiments on the International Space Station. The possibilities stretched far beyond what one camera and balloon could achieve. The project had become a launch pad for innovation, with no end in sight.
Personal growth through exploration. For the man who started it all, the project was more than a scientific endeavor. It was a transformative journey. He discovered the power of perseverance, the thrill of problem solving, and the joy of sharing discoveries with the world. Every setback taught him something valuable: how to plan meticulously, adapt quickly, and collaborate effectively. More importantly, he learned the value of dreaming big and acting on those dreams. This project started as a simple idea, he reflected in one interview. But it became something much bigger. It showed me that anyone can achieve amazing things if they're willing to try. Addressing common questions. As the video continued to gain traction, viewers flooded the comments section with questions. Here are some of the most frequently asked. How far away did the camera land from the launch site? The camera landed roughly 15 miles from the launch point, thanks to precise planning and relatively calm winds on the day of the launch. How was the footage retrieved? The GPS tracker provided real-time location updates, leading the team directly to the landing site. Why was a fisheye lens used? The fisheye lens was chosen for its wide-angle capability, which captures more of the environment. While it caused distortion, it provided breathtaking visuals. What happens to the balloon after it bursts? The remnants of the balloon are biodegradable, and every effort was made to recover as much of the material as possible to minimize environmental impact. Lessons learned. The project wasn't without its challenges, and each obstacle offered an opportunity to learn. One key lesson was the importance of thorough testing. The team conducted multiple dry runs, ensuring every component, from the GPS tracker to the parachute, worked flawlessly before the actual launch. Another takeaway was the value of collaboration. From consulting online forums to seeking advice from experts, the project benefited immensely from a community of like-minded enthusiasts. Finally, the experiment underscored the importance of storytelling. The raw footage was compelling, but the way it was edited and presented made it truly impactful, connecting with audiences on an emotional and intellectual level. The power of visuals. There's something uniquely powerful about seeing the world from above. The footage didn't just capture the physical reality of Earth, it evoked a profound emotional response. It reminded viewers of the beauty and vastness of our planet while highlighting its vulnerability. The visuals transcended language and culture, resonating with people from all walks of life. They inspired awe, sparked curiosity, and ignited a sense of wonder that only exploration can provide. Encouraging curiosity. The experiment became a call to action for viewers. It encouraged them to ask questions, pursue their own projects, and explore the unknown. "You don't have to be a scientist to do science," the man said in one video. "You just need curiosity and the willingness to take the first step." Viewers responded by sharing their own ideas and experiments, from launching paper planes into the atmosphere to building homemade spectrometers. The spirit of discovery was infectious, spreading far beyond the confines of the original project. The role of social media. The role of social media in amplifying this experiment's impact cannot be overstated. Platforms like YouTube, Instagram, and TikTok allowed the footage to reach a massive audience. But it wasn't just the visuals that captured attention. It was the story behind them. Short clips of the balloon ascending, the Earth's curvature coming into view, and the dramatic burst of the balloon became viral sensations. Hashtags like Balloon to Space and Citizen Science trended, attracting millions of views and sparking conversations about science, exploration, and creativity. The comments section on the original video became a hub for diverse opinions. People shared their interpretations of the footage, debated its implications, and connected with others who shared a passion for discovery. Debunking myths. With virality comes misinformation, and this project was no exception. While many praised the experiment, others spread myths or misunderstandings about what the footage represented. For instance, some flat Earth theorists claimed the footage was staged using CGI, while others argued that the balloon couldn't possibly reach the heights claimed. To address these points, the man behind the experiment created follow-up videos explaining the science behind his project. He demonstrated the math used to calculate the balloon's ascent rate, shared raw data from the GPS tracker, and even showed unedited clips of the camera in action. By providing transparency, he turned skeptics into believers and strengthened the project's credibility. Highlighting human ingenuity. One of the most remarkable aspects of the experiment was its simplicity. Unlike the complex machinery used by space agencies, this project relied on everyday materials and accessible technology. This ingenuity resonated with viewers who marveled at the idea that something as mundane as a weather balloon could achieve such extraordinary results. It reminded them that innovation doesn't always require cutting-edge tools. It starts with a good idea and the determination to see it through. If you enjoyed this adventure, don't forget to like, share, and subscribe for more incredible stories from around the world. Until next time, keep looking up and dreaming big.